All right, so 9.1 is on systems of linear equations. A system means there is more than one equation. And all the equations need to have the same solution. So we tend to solve them simultaneously. We know how to solve linear equations, and we've been doing that the whole time. You got an X and a Y in it. I think the easiest way to go about doing this is just dive into an example. Or X minus 3y equals 14, and X minus 2y equals 1. The first method we're going to look at is called the substitution method. Solve one of the equations for one of the variables. Substitute into the other equation. So that there's only one variable left. Sounds like this way is here. And solve. Plug the solution into the original equations to find the other variable. A lot of instructions. Give me some time to write that down.
Why are you muting me?
Because you're making a whole bunch of fucking noise and not asking questions. When you got a question, if you got a question, you're more than welcome to unmute and ask. I don't know what you're doing, fucking folding laundry or whatever the fuck's going on over there, but it was making a ruckus. All right, so one of these equations is easier to solve for one of the variables than the others. Which equation and which variable? In which equation? This is all by itself. I'm assuming you chose that one because it's got no coefficient. So if we do it, we don't have to do anything else to it. All we have to do is add 2y to both sides here. And we get x equals 2y plus 1. What I'm going to do is I'm going to plug that in for x here. And now I'm down to just y's. Trying to clean it a little bit. So if I do that, I can solve this one for y by, first off, we should distribute. So 4 times 2y is 8y. And 4 times 1 is plus 4. And I still have minus 3y equals 14. I'm going to subtract 4 from both sides and gather my y's at the same time. 8y minus 3y is 5y, and 14 minus 4 is 10. So we divide by 5 and we get y equals 2. You should take this and plug this into one of the original equations, but sometimes it's easier to go to a later one. You should plug into one up here to get x. Alternatively, we can try this one. So this one's the easiest one to do to find x because it's already solved. If you do that though, and then you should do this for no matter what you do anyways. I'm going to plug in and put that 2 in for y. So we're putting these two together right here. And I get x equals 5. So the solution is an ordered pair. 5, 2. We should verify that works in both of the original equations. So does 4 times 5 minus 3 times 2, does that equal 14? And does 5 minus 2 times 2 equal 1? So those are the first two equations replacing x and y. This is 20 minus 6. That does equal 14. And this is 5 minus 4, which equals 1. geometrically, what's going on here? So 4x minus 3y equals 14. X minus 2y equals 1.
Sorry, I just have a question. In the B, substitute into the other, what is that? Equation?
Into the other equation, yeah.
Oh.
EQ apostrophe N was a shorthand for equation. So if I do the intercepts here real quick, when x equals 0, I have negative 3y equals 14. So y equals negative 14 thirds, which is negative 4 2/3. So 0, negative 4 2/3. If I do y equals 0, I get 4x equals 14. So x equals 14 over 4, 7 over 2, which is 3.5. This is 3.5 comma 0. Just finding some points so I can graph these two lines. When x equals 0, I give 2y equals 1/2 or 1. So y equals negative 1/2. I got 0, negative 1/2. And when y equals 0, x equals 1. So I got the point 1, 0. So I'm going to sketch this real quick. Four x minus 3y is about like that. It's a straight edge to connect those dots real quick. And on this one, I've got 0 and negative 1/2, 1 and 0. And I connect these dots real quick. Got two lines. So when we say solution, or it has to solve both equations, the answer has to be on both lines. It just so turns out for a system of equations, if this was sketched well, this is 5, 2. It's the point of intersection. Point of intersection of the two lines solves the equation. That doesn't look like 5, 2 to me, but then again, my axes isn't great. I'm not using graph paper. And I kind of estimated 0, negative 1/2, and fuck, I'm not even on the lines here for this. It's just bad. But it's, you can see it's close to 5, 2. If I had graphed better, it would look better. Graphing isn't the optimal way of doing it. You got to do a lot of work just to graph it. And if the solution doesn't like cross on like a line where you can see it's a perfect integer, it's not helpful. Doing this substitution method is a great way to go. We have another method. We're going to do another method. We'll do it on the same problem here. But I want to make sure everyone's ready before we start it. Does anyone need longer on that? I'm gonna take the page away, Josue, are you good?
I'm fine, I'm fine.
So let's take a look at this same problem doing the elimination method. It's also frequently called the addition method. The big picture, the main idea here is this. Multiply one or more equations by values such that or so that the coefficients for the same variable are equal but opposite. Then add the equations together. Thus eliminating that variable. I don't know if you noticed, I opened up most of the homework to be due on the day of the final. We're getting near the end of the semester. I want you guys to have all the opportunity you can to get any last minute points and stuff like that. Understanding. All right. So the idea here is to have them be equal but opposite. If I multiply this equation here on both sides by -4, this becomes -4x plus 8y equals -4. Make sure you do it to both sides. The initial equation was 4x minus 3y equals 14, the other one. And if we add these together, we get 0x, which goes away. And then we have 5y equals 10. So 5y equals 10. Y equals 2. And plug it into one of the initial equations and solve. X minus 2 times 2 equals 1. X minus 4 equals 1, so x equals 5. And together, these two get us the same 5, 2. Any ideas? What do you guys think about the two methods? Which one seems easier? This one?
Yeah.
That's unusual. Most people like the substitution method more.
We just gotta multiply both sides and you just gotta find one that's. You just easily.
Right. There are problems where this gets harder. Like if this was like a 5 or 5x or something like that, choosing what you gotta multiply by makes them hard. Well, not really. It just means more work. The substitution method, there's pros and cons. Substitution method, if one of these is already has a coefficient of 1, the other method's really quick. If it's not, and neither of them are, it's still doable, but like oftentimes you're gonna end up with fractions. And if you end up with fractions working with the shit, don't do it. We can always do the elimination method so that we don't end up with fractions. Let me show you another way of doing these exact same problem. We know the answer here. I'm going to eliminate y now instead. Let's go with eliminate y. The easiest way to do this is grab the other coefficient. We'll just call it coef like that. I got a -2 and a -3. I'm going to multiply this by -2. Well, there's a little more we're going to do, but I'm showing the main idea here. Grab the other y's of the other variable's coefficient. So that's what I did here. Now, change the signs on one of them. I'll make the -3. I'm going to do it here. I'm going to make it a +3. This is the only surefire way to solve, well, without using matrices and stuff like that. It's a surefire way of solving these without getting fractions involved. Because fractions makes this shit harder and more likely to fuck up. The process is the same though, so why don't you try to go ahead and finish this process out. Multiply through by these, combine the equations and see if you get 5, 2 on your own. So if you multiply through by that, you should have gotten on the left, negative 8x plus 6y equals negative 28. And on the right, 3x minus 6y equals 3. Stack them up and add them, you get negative 5x equals negative 25. Divide by negative 5, and we get x equals 5. Then we plug it back into one of the original equations. I kept doing x minus 2y equals 1. I'm going to plug it into the 4x minus 3y equals 14 to show you that it doesn't matter which one we plug it into. I get 4 times 5 minus 3y equals 14. So this is 20. I'll subtract 20 from both sides. I get negative 3y equals negative 6. Divide by negative 3, and I get y equals 2. And I put them together to make the ordered pair 5, 2. Ready for more? Nope, people are still writing. All right, next one, you're free to choose which one you want to do. Although I'd be surprised if you picked anything but elimination method. Work through this, and when you get to the end, you're going to see that you get stuck. So if you get stuck when you're done combining things, it's expected. Don't think you did it wrong. You guys have a good Thanksgiving? Are you already done? We'll give the others a little bit longer. I guess it's not a long problem if you're working through it quickly. God damn it, Jimmy, you gotta start showing up to class. It's not as much fun if you're not here to pick on. The fuck, Jimmy?
In Zoom.
He's on Zoom, yeah. He didn't want to say anything, but he gave me the thumbs up. All right, so. If I multiply the first one by 2. I get 14x, 7 times 2 is 14x. 3y times 2 is 6y. And 2 times -5 is -10. And when I add these up, I get 0x plus 0y equals -20. Or 0 equals -20. Is this true? This flat out false. 0 does not equal -20. And yet, if you verify, double check your steps, everything was done correctly. This means there's no solution to this system of equations. What does that mean in terms of the lines? Did you get those baseboards scrubbed, Eric?
Yeah, painted the walls too.
Oh, fuck, she had you paint too?
Yeah,
Oh, she doesn't know she was her. I heard her. She's like, oh my God, you talk about this shit at school?
yep.
I know. I heard, oh my God, but I'm betting you, then you muted and I'm betting that was the rest of what she said.
Yeah, yeah. Now she's saying I get pretty parties at school.
He's doing really well in his class, so if you need him to do more work around the house, he's got a little extra free time to do it.
That's what he goes there to do.
There you go, Jimmy. You're not the only one I throw under the bus. I hit Eric where it hurts. I told his wife he's free to do extra work around the house. What does it mean for the lines? Any ideas? This
Like on a graph,
the what?
like on a graph.
Yeah, like on the graph.
Is it X? So. Or is it just?
Like they don't intersect.
They don't intersect. So no solution means no intersection. And what does that mean for the lines themselves? They are parallel. Yay. And I came out of left field. I'm like, oh fuck, there's a girl in here. What? First I thought I was Eric's wife coming over to answer the questions. She's like, I gotta show my husband how to do this shit. He didn't know what he'd done.
I'm upset that you didn't expect it would be me.
As soon as it took a second to process the voice, but then I did recognize it was your voice. You're not always here. Right?
Not true.
You've missed some.
Yeah, sorry.
So, hey, don't be upset. You don't know how many people I've told about our conversation this weekend.
Like in a bad way?
No,
Oh, okay.
like the 20 and counting part.
Oh my gosh. Oh, I lied. It's 12. I don't know why I told you 20.
The fuck, Hannah?
I got it wrong.
Yeah, that's a big wrong.
And also
12 is still a lot.
yeah. Well, also my boyfriend told I told you about the pork thing.
Uh-huh.
He told me to tell you that I eat ketchup on eggs because he said that's worse, but I don't think that's worse.
That's not worse.
Yeah, I know.
This poor girl didn't get any turkey on Thanksgiving. That's some fuck shit right there. All right, so if we do this one. I multiply by 3. Because I see that 3x times 3 will give me a 9x. So I have 9x minus 3y equals 24. And I'll bring this line down underneath it so that I can add them up together pretty easily. And I add, and I get 0 equals 0. Which is true. That's a fact, Jack. This means the answer is not dependent. Answer / solution is not dependent on a specific X or Y. And what this means is all solutions that solve one line solve both. And the way this comes about is these are the same line. If you graphed, it would be a perfect overlap.
So like one line together.
What?
Like one line together.
Yeah. Which means if you reduce them to the like slope intercept form, you'd have the same equation. In fact, if you did that, you will see on both of these y equals 3x minus 8 for both. But enough of this kitty mode shit. 2 equations is for high school students. We're college students. Let's kick it up. You guys ready? Ready to bring your A game? 3 equations with 3 unknowns. Yay! Upgrade. Let's throw in a Z. So the idea here is try to eliminate a variable with substitution or elimination in 2 different equations. So that you get down to 2 variables, 2 equations. And then you're in territory you know how to deal. So I'm gonna put letters on these. I'm gonna call this equation A and B and C. Now, we have some options. C makes it so we can do any 2. Because they all have a coefficient of 1, so if I just multiply by the right number, I can add to one of the other equations and work well. I see that for me, I like getting rid of Z because I can see that the top 2 already would cancel out. So let's try that. Let's add A plus B. So I'm going to stack them and add them. I'm going to call this D. And now I need to get rid of Z in another equation. I need to have another combination. I combined A and B, so the next combination has to have a C involved. If I do like A plus 2C, so I'm gonna put a little circle around this one so it like stands out. If I do A plus 2C, I've got 3x plus 4y minus 2z equals 14. If I multiply C by 2, I have 2x minus 2y plus 2z equals negative 18. So that when I add them up, I have 5x plus 2y equals negative 4. And I'll call that E. We have a couple options here. we could divide by 5 to simplify this equation. But I see that E and D both have 5x. So if I just do something like D minus E, make sure the subtraction hits both. So 5x minus 5x is 0x. 5y minus 2y is 3y. And 5 minus -4 is 9. Divide both sides by 3 and I get y equals 3. Then you start working backwards. As soon as you have one of the solutions, take it and plug it into either D or E, into here or here. I don't know. I'll plug it into E. I have 5x plus 2 times 3 equals -4. So 5x plus 6 equals -4. Subtract 6, I get 5x equals -10. Divide by 5, I get x equals -2. Now that you're down, now I have 2 of the variables solved, I know what they are. Then plug into one of the original 3. I think C is the easiest one to plug into. I have -2 minus 3 plus Z equals -9. So Z minus 5 equals -9. Add 5 to both sides. I get Z equals -4. And we end up with -2, 3, -4. Which is called an ordered triple. It represents a point in 3D space. And then let's take a little 5-minute break, give people time to go to the bathroom real quick if they want. Or for those that went to the bathroom already, catch up on what's on the screen.
I have a question.
Yeah,
How did you know, or like, what was your process, I guess, to picking like the first 2 equations to plug in to get D and E?
okay, so I saw that -2Z and 2Z were opposite.
Mm-hmm.
So I didn't have to do anything but just add as is.
Okay.
I could have done the same thing with B and C,
Mm-hmm.
because Y and -Y would have canceled out, which is a valid approach. There's more than one way to solve this,
Okay.
but the solution is gonna be the same no matter which way you do it. So if you had isolated y, eliminated y, then we'd have to eliminate y and a as well.
Mhm.
Using one of these, I would probably multiply c by 4. So that I would have a -4y that would cancel a +4y.
Mhm.
And then our two equations here, D and E, would have x and z rather than x and y, because we got rid of y.
Okay.
So. But pick whatever's easiest. X is the most amount of work, and it's still, even in this case, X isn't a lot. I would just have to multiply C by a different negative number both times. I could do C times -2 and add it to B. And then I could do C times -3 and add it to A.
Okay.
And then I would get down to Y and Z for my two equations.
Okay, thank you.
Yep. Pause it for a few minutes. All right, let's do one more idea in this section. Oh, there's two more ideas I want to do in this section. So here we're gonna have two equations with 3 variables. I want you to see what happens when we go through this. I can't get it down to a single point. To get a final answer, we need single point solution. We need as many equations as unknowns. So we can't get a final point, but we can narrow it down. So what I'm gonna do is I'm gonna let's see, we can either eliminate Y or eliminate Z. I'm gonna let you guys pick. I don't want to do with X because they have 3 and a 5. You guys want to get rid of Y or Z? First person that spits out one of the letters. Y. Y. All right, so we're gonna get rid of Y. So what I'm gonna do is to get rid of the Y, I need to multiply this by -2. If I multiply this equation by -2, I'll get a -2Y there. And when I add them up, the Y's will go away. So that's the logic there. So -2 times 3x would be -6x. -2 times -z would be 4z. And -2 times -7 would be +14. And when I add these up, I have -x plus 0y plus 5z equals -8. So if I add x to both sides and add 8 to both sides, I can at least get the letters on different sides. I get 5z plus 8 equals x.
Jefe, on the -8, is it +8?
It's positive 8.
Okay.
So I'll subtract 8 there, and now it'll be a negative 8 right there. Good catch. I'm glad you didn't wait till the end. All right, so once we have that, we're gonna plug this into both original equations. So I have, let's see. Well, I really only need to plug it into one. Let's plug it into the one with the smaller x. Let's plug it into the 3. 5z minus 8 in place for the x, plus y minus 2z equals -7. Oh, that's a good choice because y is already by itself. And what we're going to try to do is get this one down to y as well. So I've got 15z minus 24 plus y minus 2z equals -7. And I'm just going to do these all at once. I'm going to subtract 15z over. I'm going to add 2z to both sides. I'm going to add 24 to the other side as well. All I'm left with on the left side is y. On the right side, I've got -15z plus 2z is -13z. And -7 plus 24 is plus 17. So I've got x in terms of z and y in terms of z. The best we can get down to is instead of having x, we will have 5z minus 8. Y will be -13z plus 17. And z is just z. Z is a parameter here. So like when z equals 0, this is -8, 17 and 0. If z equals 1, I have 5 minus 8 is -3. -13 plus 17 is 4. And 1. And we could do this for a lot of z's. This makes a line in 3-dimensional space. And we could have parameterized for other letters, but we've got to have something that acts as a variable here. Oftentimes, what you'll see, especially when you're looking at another fields and stuff, they'll say z equals t for time. And then they'll call this 5t minus 8, -13t plus 17, and then t. And now t is the parameter. Let's see some fun, some cool. Do like there's lots of applications for this. You can set up word.
Wait. Just a minute. Just a minute.
There's lots of word problems and stuff like that. I'm gonna do one that's a little unusual.
I'm done. I'm done.
Let's start with 3 points. We're gonna have -5, 7, -1, -2, 3, 5. There's some sort of parabola. These don't go out line on a straight line, right? So if I wanted to connect them, ways I could connect. Likely the model would be a parabola. Which is in the form y equals ax squared plus bx plus c. Now, let's see, this is 4 to the right, and that's 4 to the left, but they're not an equal height, so this is not the vertex. I'm guessing the vertex is a little over here, but I don't know where. I'm guessing it's gonna look something like this. But I'm not certain, sure. That's just a guess. Let's find an equation for this curve. Using our 3 points. I think it's something like that. That looks like the most likely way that they would connect as a parabola. There's definitely no way of connecting them as a line. Couldn't connect them as a cubic because they should keep increasing or decreasing. So parabola seems like something I could do. I've got the equation y equals ax squared plus bx. What if I plug in the 3 points into y equals ax squared plus bx plus c? So if I plug in the first one, I've got 7 equals a times 5 squared plus b times 5 plus c. If I were to rewrite this, I would probably say 25a plus 5b plus c equals 7. If I do with the next one, I've got y equals -2. I'm gonna plug in x equals -1 for each of the x's. And this is gonna give me a squared minus b plus c equals -2. Finally, if I plug in the last one. I get not 9a squared, I get a, that was a minus b, a wasn't squared. 9a plus 3b plus c equals 5. Over here, I have 3 equations and 3 unknowns. I can solve these for a, b, and c and figure out what the coefficients are. C is has a coefficient of 1 in all of them, so like if I do like a minus b, I get 25a minus a is 24a. 5b minus -b is going to give me plus 6b. The c's go away, and 7 minus -2 is positive 9. Hold on. That was a -5. Which makes that a -5b. That's going to change this. I have 24a still, but it's going to change the b's. -5b minus -b will give me -4b. The c's went away, and the right side was still 9. So this is like equation A, B, and C. I didn't label them earlier. Maybe a B looks like the easiest one to work with on getting rid of, so I'm gonna do C and B. I'll do C minus B. 9a minus a is 8a. 3b minus -b is positive 4b. C's go away, and 5 minus -2 is 7. Now we try to eliminate another variable, and conveniently the b's in this one have opposite signs already and opposite values. So I can just add them up, and I get 32a equals 16. So a equals 16 over 32 is 1/2. I'll stick 1/2 into one of these, preferably the smaller one. We've got 8 times 1/2 plus 4b equals 7. So that's 4 plus 4b equals 7. Subtract 4, and I get 4b equals 3. Divide by 4, and I get b equals 3/4. So I've got a equals 1/2, B equals 3/4. Now I'm gonna plug in one of the original equations. I'm gonna plug it into B. A minus B plus C equals -2. 1/2 minus 3/4 plus C equals -2. If I get a common denominator, this is 2/4 instead of 1/2. I get C minus 1/4 equals -2, which is -8/4. And if I solve for C, C equals -7/4. Not pretty, ugly fractions, but it is what it is. The equation for that parabola is y equals 1/2 x squared plus 3/4 x minus 7/4. We found an equation for the line given the 3 points that we had.
I just have a question. Did you replace the A by 1/2 or? Because,
Yeah,
yeah,
right here.
it shouldn't be. Wait,
16 divided by 32 reduces to 1/2.
1/2. Oh, okay.
I mean, you can use 16/32 if you want.
Then from where is the 2/4?
I wanted to be able to combine 1/2 with 3/4. 2/4 is the equivalent of 1/2. I just got a
Oh,
common
okay. Oh, so it's
denominator.
the same. Oh, okay, it's the same.
All right, I want to show you guys one problem from 9.5. I don't think I'm going to test you on 9.5, but you need to see how it works. Is there any other questions on this? It's kind of neat. We found an equation that fits 3 points that were not on the line. So 9.5 is on nonlinear systems of equations. Which means at least one of the equations is not a line. Which means it's going to be a curve of some sort. For example, x squared plus y equals 6, and x minus y equals -4. So x squared means there's going to be 2 answers that meets this one. So maybe the best way to find this is to combine these where I just have x's left. So like, let's solve one of these for y. Solve for the non-squared variable. On one of them. If I do that here, this makes this y equals x plus 4. You can get that by adding y to both sides and adding 4 to both sides. You get y equals x plus 4. What we're gonna do is we're gonna take that and we're gonna plug that in up here. And if I do, I get x squared plus x plus 4 equals 6. Well, we've done these before. We know how to solve these. We want to solve these. We want to get one side equal to 0 by subtracting 6 from the other side. So I got x squared plus x minus 2 equals 0. You all right, Luis? Okay. What's that factor into? Should be x plus 2, x minus 1. The bigger one's got to be positive, end up with a positive. So if we set each of these equal to 0, we get x equals -2 or x equals 1. Then we can go and plug them into y. And I'll do that here. Y equals -2 plus 4. So y equals negative or positive 2. So I got the point -2, 2. And if I stick in 1, I got y equals 1 plus 4. Y equals 5. I got the point 1, 5. Let me load up Desmos and let's just take a look at it and see if this makes sense. I'll bring that back in a second, but just to show you, one of these is the x squared plus y equals, or x squared plus y equals 6 is a parabola opens down. X minus y equals -4 is the red line. They intersect at -2, 2, like we had, and 1, 5. So we found the points of intersection. Kind of neat, huh? What you really want to do once you have these is make sure the system, make sure each solution satisfies all equations. It's a good idea to do with the linear equations as well, just to make sure you didn't make a mistake. When you have nonlinear things, it can introduce errors. So I would plug in the -2, 2 into both of them. This becomes -2 squared plus 2. Does that equal 6? 4 plus 2 equals 6. That's good to go. And then I'll plug that into x minus y equals -4. Is that true? -2 minus 2 does equal -4. So that one works on both of them. Do the same with 1, 5. 1 squared plus 5, does that equal 6? And does 1 minus 5 equal -4? yes on both. 1 plus 5 is 6. 1 minus 5 is -4. So that equation works on both. Ready for some more?
Wait. I'm ready.
Good.
Yeah.
Let's see. There's a variety of ones I could do. Let's show you a shitty one. Just so you see how to do a shitty one. So what I'm seeing here, the first thing I would say is, well, if I see them stacked above one another. It looks like if I add them up, I can get rid of the XY. So if I add them up, I get 2x squared plus 2y squared equals 30. And if I divide by 2, this becomes x squared plus y squared equals 15. This is a circle, radius square root of 15. We've done circles. The other thing I could do is I could subtract. I could say x squared plus xy plus y squared equals 21, and then subtract x squared minus xy plus y squared equals 9. If I subtract x squared minus x squared is 0x squared. Xy minus negative xy is plus xy. We get plus 2xy. The y squareds go to 0 also. And 21 minus 9 is 12. So I have 2xy equals 12. If I solve for y, I get y equals 6 over x. So maybe I'll plug that in up here. I've got x squared plus 6 over x squared equals 15. Nice square top and bottom. I'm gonna multiply through by x squared because I don't like fractions. This becomes x to the fourth plus 36 equals 15x squared. Or x to the fourth minus 15x squared plus 36 equals 0. I could say u equals x squared here. If I say u equals x squared, then u squared is x to the fourth. And this turns into u squared minus 15u plus 36 equals 0. This factors into u minus 12 times u minus 3. And if I put the x squared back in, I have x squared minus 12 times x squared minus 3. So I said each of these equals 0. X squared minus 12 equals 0, or x squared minus 3 equals 0. I get x squared equals 12, or x squared equals 3. And I'll take the square root of both sides. I get x equals plus or minus square root of 12, and x equals plus or minus square root of 3. Square root of 12 is 2 root 3. So if I take these and plug these in up here, we're actually not going to get all the answers we want. We actually need to plug them in up here. When you do x equals plus or minus 2 root 3, you're going to see y equals plus or minus square root of 3. And when you do x equals plus or minus square root of 3, you're going to see y equals plus or minus 2 square root of 3. So you actually get 8 points. 2 root 3, root 3. 2 root 3, negative root 3. Negative 2 root 3, root 3. Negative 2 root 3, negative root 3. That's all the combinations of the first pair here. And if I do the second pair, we have the square root of 3 first. So square root of 3, square root of 3. I had 2 of each. 2 root 3, negative 2 root 3. 2 root 3, negative 2 root 3. And that comes from here. It turns out y equals 6 over x would have been the better one to plug these into, because this one is bad. That one is bad. It doesn't work in the original equations. This one is bad, and this one is bad also. Only the ones where the signs match on x and y doesn't work in the initial equations. Hey, is that true? Yeah, that's true. So not all of them work. If you're doing one of these, I'm just gonna point out like a process to do. If you had something like x squared plus y squared equals 4, and y equals the absolute value of x. Y equals the absolute value of x can be a pain in the ass to deal with, the absolute value, of course. But if you square it, you get y squared equals the absolute value of x squared. And anything squared is positive, so you don't actually need the absolute values anymore. So you can deal with the absolute values by squaring. I don't think I'm gonna have this on the test, but if I do, it's probably gonna be the extra credit. Something like one of these nonlinear systems of equations might be the extra credit problem on the final exam. And with that, I bid thee adieu. Get the fuck out.
Hey, Jefe,
Yeah,